We have our blockchain node server started up. Let's add one API and obtain the information from our blockchain. For this, let's go to blockchain_server.go, and then we're working with Hello World. But for this lecture, let's add on a different API. We don't want to create a blockchain every time there's a request made for the blockchain data. Once it's made, we want to store it in our cache. For this, we'll enter cache map, string, then blockchain. And we see above that Go blockchain block has automatically been imported. Going back to where we left off, this will be followed by make, map, string, blockchain. What we've done is in our global, we've created cache, and inside this, we want to place the blockchains that we'll be creating from now. Let's go under our section for port and add on from here. And what does this mean? We have our blockchain server, and here we'll write get blockchain returning blockchain. Then we want to obtain our blockchain, but right now we want to know if it's inside our cache or not. For this, we're going to write cache, then blockchain, which is what we declared above in our map. We want to see if the blockchain struct is included in our map above. At the very beginning, it doesn't exist. So when we don't have any, this is what we do. When we generate our blockchain, we need to first register the miner's address. That's why we're going to write wallet, then new wallet. We see above that Go blockchain wallet has automatically been imported. We'll be using this miner's wallet, and next we'll be writing BC block new block. This means that when we generate our new blockchain, we'll be registering the miner's blockchain address. And one more thing, we'll pass in BCS port. That's because later on we'll be using the blockchain's port number to research the address of the surrounding blockchain node, which is needed to sync the information. We have our port numbers here, and we want to register our port numbers as well, so let's go inside our new blockchain. When we do, we have our blockchain struct. We'll create a new line with port, then write uint16. Let's look at this new blockchain, and here we'll also pass in our port. We'll also create a line for BC port. This is how we're going to include our port information inside our blockchain struct. Now that we've completed this, let's go back to our blockchain_server.go. We just generated our blockchain, so we'll include this in our cache. Inside our key containing blockchain, we'll include the blockchain we just created, then followed by return BC. When the blockchain is inside the cache, we'll return the blockchain as is. If not, at first we'll be creating a miner, then registering the miner's address, then moving forward with our blockchain node. And regarding our miner's address, we'll want to refer to it later on too, so we'll include a log statement. It's usually not recommended to write private key for the log, but this is just a demo and we'll use this later on. And now we'll write miner's wallet. This will be followed by private key str. We'll copy this line and make this public key str. We'll replace this to public key str. Then the last line will be blockchain address. We'll rewrite this part too. Now on to our hello world here. Let's make some space here. And we don't need our hello world anymore. So let's delete this and write func bcs blockchain server as our method, followed by getChain. Later on, we'll register this in this bottom section here. For this, we'll write whttp response writer, followed by rec http request. Later on, when working on getChain, you might want to use this at a different time too, so we'll write request method. Here, we want to determine if this is HTTP method get or not. When this is a HTTP method get, then we'll take this action. And if not, then we'll do a different action. For example, we'll write default, then log printf error, invalid HTTP method. We'll write our condition for when this is HTTP method get. Let's write bcs get blockchain. This blockchain we want to return as JSON, so let's go to the folder inside our project. And let's open up blockchain.go. Right now we have new blockchain. For this new blockchain too, we want to write the code for marshalling. For this, we'll write blockchain. This will be followed by marshal, JSON, byte, then error. Next will be return JSON marshal, struct, blocks. This is our pointer. Then JSON chains. We want to return a list with our blockchains, so we'll write blocks BC chain. We'll JSON marshal this, and this block is the marshal section. And when we scroll towards the top, we are marshalling. And previously, we stated that our previous hash is 32 bytes. But when we're doing JSON marshal, 32 byte will make the result hard to read. That's why we'll change this to string and change our hash to fmt sprintf %x, which means that we'll rewrite to a hexadecimal numeral. And moving on, let's go back to our blockchain_server.go and include our current JSON information. We'll include BC marshal JSON to call on this directly. Then IO write string, we'll specify W, then we'll include RM. This is JSON, so we'll write W header. Then add, then content type as our type followed by application JSON. Then all we have to do is at the bottom where we have the hello world, we'll rewrite to BCS get chain. Once we've gotten this far, let's try running our code. We'll run our code and access our 0005000. And we see below the log that we previously wrote. We have our private key, public key, and blockchain address. The miner's information is displayed, and with get chain, you'll be able to access the chain information that's inside blockchain using JSON. The browser on the right is Chrome, but when you use Firefox, the JSON information is displayed neatly like this. So if you prefer to see the results in an organized format, then you may want to consider trying using Firefox. In this lecture, we covered how to add the API to retrieve the chain information using getChain. Now let's move on to our next lecture.